So I would now like to invite on stage our panelists to join us. Dr. Anil Kakotkar, Chancellor Homi Bhabha National Institute, Dr. Arun Kumar Nayak, Nuclear Control and Planning Wing, Department of Atomic Energy, Dr. R. Divakar, Director, Metallurgy and Materials Group and Materials Science Group, Indira Gandhi Center for Atomic Research, Dr. Vijayan Palipattu, Senior Professor, IIT Jammu. The session will be moderated by Professor Ashok Jhunjhunwala, the President of IITM Research Park and Incubation Cell. Can I request all the panelists to kindly take your seats on the dais?
So what we like to do, we'll like to further discuss this and also make it interactive. I want to straight away point out that there, as was pointed by Dr. Kakotkar, there is no option but to have enough nuclear complementing solar, wind, and other sources of energy. That is given. As was pointed out, tomorrow we have a 4-hour brainstorming specially on micronuclear. But today it is more general, micronuclear as well as nuclear per se. So what I will do is that since Dr. Kakotkar has just spoken, first I'll request each of the other 3 panelists to speak for about 5 to 6 minutes, and then we will get into discussion.
Respected Dr. Anil Kakotkar, Professor Jhunjhunwala, Professor Vijayan, and Dr. Nayak. I'll try to be a little louder. Yeah. So it's an honor and a pleasure to be here. My name is Divakar. I'm from the Indira Gandhi Center for Atomic Research, which is about 60 kilometers from here. We are focused on establishing fast reactors technology in the country. That is our main mandate. And towards that, we have a test reactor that has been running for over nearly 4 decades now. And it's a unique reactor, a small reactor in current parlance, it could be called. Recently, we have taken it to the full power and also demonstrated all kinds of sodium technologies with it. Now, this test reactor has enabled us to establish ourselves as a master of sodium technology in the country and also in the handling of various kinds of high plutonium fuels and other things, right? So all technologies for fast reactors we have learned from this reactor and also use that for various kinds of material studies and enabling the fuel technologies that go into it. Now, to come to the focus on today's meeting, Indira Gandhi Center for Atomic Energy as such has been involved with Bhavini, and we are about to commission the fast reactor. It is well on its way to commissioning the PFBR 500 megawatt electrical. And as Dr. Kakotkar pointed out, these large projects are still of relevance, and we are going to have a series of fast reactors on site there. This enables a sustainable way of bringing in nuclear energy and employing nuclear energy for the development of the country. This is a given. Having done that, where are we going forward? We are going forward in several ways. Of course, newer technologies, greater indigenization, more optimization of the reactor technology, further improvements in the manufacturability of the various components, bringing down the construction time. All these are imperatives for the big projects. Apart from that, what do? We are looking now at having a SMR, small modular reactor, and working on the design for that, and whether we can make it a fast reactor based on metallic fuel with breeding. This is important to, in the overall scheme of the DAE programs, this is important for sustainability of the program over long years of time. This is going to give us the guaranteed energy sources for over a long time. That sustainability part is very important because we follow a closed fuel cycle. Having said that, this design, what we have done really towards this, how have we worked towards this is to set up a task force on that. We have a task force working dedicatedly on a design of to arrive at a SMR design. This would be somewhere in the 100 megawatt range, and we are aiming to see how high the burn-up can be how high the breeding ratio can be taken. And these are all very important imperatives to ensure that the system is sustainable. Now, with this, we would be able to establish technologies required for that. Various technologies go into that, both the core technologies as well as the balance of plant, all are important. When it comes to SMR, the middle letter, modular, is important. And this has some challenges over and above what we face with the brick projects. So modular implies manufacturability. There are materials challenges, there are materials manufacturing challenges, which are again opportunities, as I see, in bringing this technology to the world. The other point that has been highlighted is, what do we produce? Do we produce just electricity? Or going forward, do we need to do something else, something additional? So one of the ways that IGCR is thinking of moving forward is to see if we can use our test reactor to produce hydrogen. Now, initially, yes, there are established technologies, as Dr. Kakodkar also pointed out. We take in a known alkaline electrolyzer, hook it up to a FBTR. It produces about 10 megawatt. You get use of 6 of so of that, produce a certain amount of moderate amount of hydrogen. This would be based on available technology. But then what is the challenge? The challenge is to see whether that efficiency factor that we lose, in converting the nuclear heat to electricity, can be sort of overcome by directly using the nuclear heat. There are many technologies that need to be established towards it. There are many innovations that are waiting to be made to be able to directly use nuclear heat. There are some established chemical processes such as iodine, sulfur, etc., which can be implemented today to use nuclear heat. But then these are processes that that are not completely satisfied by the temperature, the maximum steam temperature that we are able to achieve that. So just to close, what I would say is IGCR is involved in these developments. We are also a constituent institute of the Homi Bhabha National Institute, under which we involve academically, academicians and research. We have an incubation cell through which many of these technologies can be co-developed with interested parties also. So these are some of the ways that we can move forward on the small modular reactors, especially based on fast reactors.
Good morning.
Please be brief so that you can get
Speak in 2 minutes.
interaction with the audience.
So, first of all, thankful to IIT Madras for giving this opportunity to speak. The essence has already been spoken by Dr. Kakodkar in his keynote lecture. So, we have to build up on that. Just I wanted 2 things. Suppose it is asked to all of us to decarbon today's energy sector and be energy secure today. What is the issues? I will say that most of us have not addressed even that. Forget about our growth. And we say by 2050, end of Amrut Kal, we want to be a developed nation. And by developed means, is it 28,000 terawatt hour per year? Because today China's per capita energy consumption is 4 times that of us today. And if I just calculate that one, it's much bigger than 28,000 terawatt hour per year. So there are 2 major challenges for all of us. Suppose we want to produce even 2,500 gigawatt electric from nuclear. And today we are only 7 gigawatt. I will say that 70 to 75% of India's technologists, scientists, even academicians, it is not there. This is the first and most important part. Second part is taking the public, convincing the public, the outreach part, that without nuclear, this country can never be developed. It will be continue to be a developing nation. Third and most important part is the technologies which you are talking about, whether it's small modular reactor, micro reactor, anything. What time frame we have? It is just 2 to 3 decades left. Not much time is left. So can we all work together by making consortiums or making, I will say that, collaborations with national, international platforms to build it up. Last but not the least is the fuel security. We have very, very limited amount of uranium unless we go for second stage and third stage, that is fast reactor based or for thorium solutions. This energy requirement cannot be met by our one fuel, that is uranium based fuel. So these are the challenges. Time is small, lot of money is involved. In my opinion, almost trillions of dollars have to be spent if you have to be energy decarboned and develop this nation. So where is the money coming? It cannot come from government. Lot of private investment has to come. Then only we can be a different nation. More we'll talk during the question answer. I break here, sir.
Thank you. Dr. Vijay.
Good morning to you all. Well, a lot of things have already been said. So, Kakodkar Saab rightly pointed out, if nuclear has to play a big role, it should include multiple capabilities, which means large nuclear reactors, SMRs, micro SMRs, and even medium SMRs. Although SMRs are less capital intensive, but they have many, many challenges. First of all, they have to be intrinsically safe, which is very important. See, there is no exclusion radius or emergency planning zone. Just outside the plan boundary is the public. So, this is not so in the large power plants. For the small nuclear reactors, they have to be definitely intrinsically safe. Cannot have, even if something happens, as he said, it has to be inherently safe. The passive means has to be ultimately taken care of. I agree with all these. But I have some issues about the cost. If you recall, the large power plants, see, the nuclear started with, the small power plants, 50 megawatt in that range, the first grid connected. Then they went on to increase the size, basically to bring down the price. And in spite of, going as much as 1600 megawatt electric today, now we are coming back to micro and, that too, so 4 or 5 megawatt. Remember, when you go down, your cost per megawatt electric is going to go up. And that is reflected in the already operating SMRs. If you look at the Russian SMR, KLT4S, it is 112 crore per megawatt electric. It is already operating. And the Karam, which is under construction, they are talking about 192.7 crore per megawatt electric. There is a possibility, if you go for, say, small BWRs, they have only one component. There is no steam generator, no pump, just one component in the nuclear island. They can be, actually, if you look at the cost that is talked about, is the least among them. So there are better possibilities, maybe the fast reactors being, low pressure, high temperature reactors, they have better efficiency, and there is a possibility of being more economic. So these are the issues which we need to look at, So if we say that micro or medium or large SMR, are we going to be cheaper than the already operating large power plants? Thank you.
Thank you. Friends, the agenda for brainstorming is there. I think it's working. Am I audible? So, agenda for brainstorming is there on the screen. And the idea is to have an interactive discussions. So, and to enable maximum number of participants to participate, each one of us don't give long speeches. Please be very crisp in whatever comments you want to make or whatever question you want to raise. It's not a question answer per se, it's more a discussion. So, but in any case, please be brief so that you can accommodate large number of such comments. Before I invite that question, I think the comment which Dr. Vijayan made was very important. And the reactor sizes became large to benefit from economy of scale. Now people are talking about small systems because to find so much of capital at one stage becomes difficult. So you bring this size small, you can do with less capital total, but the specific capital cost, rupees or crores per megawatt, that decidedly goes up. And the only way to combat that is to bring in economy of mass production, volume. And so, particularly in the context of the smaller reactors, or more particularly the micro modular reactor, one has to think of systems which can be mass manufactured, and also systems where fuel you can create a service for fuel where you take the spent fuel, process it, bring it back, and that activity will be decidedly in government domain. But if you configure a design for a business of this kind, I think there is a chance of bringing it small. So keep that in mind while making your comments. But I would invite participants if they want to make any comments. I hope the mics are there. Can we reach mic there? Somebody is asking the question. We can take something like 4 or 5 quick questions collectively, and then I'll get back to the panel for responding to that, and then panel can make additional comments. Please, very briefly.
Yeah, my name is Vijay Chakrabarti. My question is going from 7 gigawatts to 2,500 gigawatts, which is what we are thinking nuclear should contribute. I don't really see a big role for micronuclear. First of all, they are going to pose a big challenge in terms of handling the fuel-related security issues, number one, because if you are distributing everywhere, fuel handling will be a big risk there in terms of handling nuclear materials. The other thing I feel is, if we put our focus on large reactors, 1,000 megawatts and et cetera, we have a good chance of reaching the target. That's my opinion.
Thank you. Maybe I should quickly respond to that. Your point is absolutely right that in terms of 2,500 gigawatt, first of all, even if you put all the reactor system, whether we'll reach 2,500 gigawatts or not, I have doubts. I'm only saying that in the context of requirement.
You want to go first?
But having said that, the role micronuclear systems can play, but in terms of distributed source of energy, I think it will have its own importance. But more important than that, I think it will create a new ecosystem in the country for development of such systems, leveraging the power of, new youth or new innovative spirit of this country. And that, to my mind, is much more important. How to make it cheap, we'll come back.
My name is Ramesh. I'm associate editor with the Business Line newspaper. In the mid-2000s, I know that BARC was involved in something called Indian High Temperature Reactors for producing hydrogen. We haven't heard anything about that after that, maybe because hydrogen was not very important at that point in time. But now everybody is talking of hydrogen. Is it being brought back? What can be said about that now? Anyone can answer, please.
Yeah, we'll take up later collectively.
Yes.
Yeah. Okay, let's get some 2 or 3 more questions.
Okay.
Yeah.
See, I have just 2 short questions. One is from the experience of the airline industry. What we have seen is the moment it is privatized, it expands like hell. So long as it is in the government operation, government hands, it hasn't shown much progress. So therefore, are there any directions in which this is probably going to happen? That's number 1. And number 2, as Dr. Naik pointed out, if we want to grow very fast, then in the education sector, we need large number of students who can actually man many of the industries, participate, etc. See, right now, when the students are not seeing opportunities at the moment because they have to be picked up right away in 2, 3, 4 years, is there anything which is going to be done? Thank you.
Thank you. 1 or 2 more.
Just a follow on that question itself. We have seen a massive boom in the space sector. Like a lot of companies and a lot of startups have come up in the space sector after the opening of the segment over there. Why can't similar policies be adopted in the nuclear field? And what are the key hurdles over there? And how is the government or the policymakers thinking about it?
Okay. 1 more. Yeah, there. I think let's also go to the front row.
Maybe
Should
2
not
more.
monopolize the. Yeah.
Quick question. Look, a very good discussion. My name is Narsimhan. I run a consulting firm in climate tech. One of the riddles I've been having is the levelized cost of nuclear energy from the large power plants. Different sources give me different data. So here are experts. Maybe I can get something validated. The levelized cost. Solar is now $2.50. What is it for nuclear?
Yeah, okay. I think let's take one from the back.
Thank you, sir. This is Mahesh from Hyundai. In this particular sector, whether corporate companies have any role, and if so, what kind of role? I wish to understand. Thank you.
Thank you. I think let's come back to the panel. So I would again, we'll go around like that and take whatever question you feel comfortable with answering. All remaining I'll answer. So but in any case, be brief because sure. I would, if possible, I would like to take a second round like that.
Yes, sir.
And if you have any further points to make, additional points independent of this question, please feel free to do so.
Sure.
Constraint is time.
Sure, sir. Just to take the first one with respect to cost, as is envisaged, the modular construction in numbers, that is in scale, has to happen, and that would really take care of the cost. And now, how does this happen? This has to happen through new manufacturing technologies. There are newer technologies these days, either laser-based or additive manufacturing, that kind of thing, which are amenable to automation, which are amenable to scaling up of production processes, and these should be brought in to control the cost. Now, the other thing, I think role of private was asked. The role of private has to, I think, okay, I'll leave that for the later one. The hydrogen production is definitely imperative now. Earlier efforts, I think Dr. Naik will be able to talk about. Fast reactor is particularly suited probably from the sustainability part. Sustainability also lends itself to economics, essentially.
Yeah.
I think most of the questions Kakurkar Saab can directly answer, but
No, I want to clear everything so that nothing is left.
So let's come back to the questions. One is the BRC program of high temperature reactor. I think there was a question here. What is the status today? See, we started the high temperature reactor program just at the beginning of 2000. That's what you might have seen, 2005-06. At that time, this decarbon was never the question. Climate change, if I take away everything, we don't need nuclear at all. We can go ahead burning coal, oil, gas, the traditional way we are doing. All that we are here, all nuclear scientists, because of one major thing, we want clean source of energy. And that is why hydrogen is coming, electricity is coming, everything. That is point number one. So with regard to the high temperature reactor program, because it was not in the thunder that time, it was moving slowly, and it has moved slowly. It has two major objectives. One is burning thorium, which Dr. Kakurkar said, that is our biggest objective. We have the largest reserve of that. And second objective was to go to a temperature where we can split water to get hydrogen. Because it had gone down slowly, because thorium is considered beyond 2050 that time, we have restarted that program. And today, our not only high temperature reactor program based on that design, but also other designs also are being considered. For example, the gas-cooled reactor where we can go still high temperature. So this program is still on. It is not that taken away. That is point one. Sir, can I answer some more questions?
Yes, quickly. Yeah, go ahead.
Now the next...
One more minute, then we'll come back.
The next question, I think from the other side, it was being questioned, or it is being questioned, it will remain in all your mind. What is the cost of nuclear electricity vis-a-vis other resources? I think there are some questions. I have some numbers in mind, I can speak it out. For example, you use supercritical coal, thermal power plant. The cost is around 4 rupees 70 paisa per unit of electricity. The moment we put carbon capture and storage, the cost is 11 rupees something, or that number. Solar is 2 rupees 60 paisa, the number what is spoke is correct. Moment we put the battery storage, the cost is 11 rupees plus. Anything, solar, wind, bio, anything, the moment we put the battery, the cost is plus 10 rupees and all, except the gas. On the other hand, nuclear, today, our latest one is around 5 rupees 20 paisa, the number. It may be lesser, well, Kakurkar Sahab knows much better. This is the number one with regard to the economics of the part. The other part which is being talked about, even what Dr. Bijayan mentioned, SMR, the economics is not the correct thing. If today we also build a PHWR, taking the technology from Canada directly put it, the cost of electricity will be double that number which I spoke. Why? Moment it is imported, the cost is several times higher, 2 times, 3 times, 4 times. All these SMR microreactors, the moment we make in India, design, manufacture in India, the cost will be 1/3 to 1/4 what the international people are claiming. So both to the volume as well as to make it in India, it will be definitely economically competitive. Sir, I think.
Dr. Vijay? Yeah. So I tend to address two questions. One on that applications of SMR and MMR, So it is rightly said, I don't think, if you take cost per megawatt electric, the smaller reactors can never compete with the large reactors. However, there are certain applications like, actually it was being talked about today, especially remote areas, where there is, so there you can have small standalone nuclear power. And another thing which I look at is, solar renewable or solar nuclear or even solar PV hybrids. What is the problem with the solar PV, etc.? They are only available during solar hours. So if you really want continuous operation, you have to have hybrids. And remember, sun is a socialist. Unlike, we, humans, the Russians, the Chinese, and we in Kerala also tried democratic communism or socialism. It didn't succeed. But remember, sun is a socialist as scientifically as possible. He has distributed energy, throughout the world as scientifically as possible. Now, in my opinion, there is no point in making a very huge power plant and try to redistribute because sun has already done the job of distributing, and you concentrate it and make a big power plant and redistribute, and then entail what we call the transmission losses, which is about 30 to 35% in India. Whereas in developed countries, it has come down to 15%. But in India, the transmission loss itself is 30 to 35%. So these things can be avoided if you have a small micro reactor. You have, say, for example, 2 megawatt electric solar thermal power plant. You can easily hybridize with a micro nuclear reactor. And that you can do anywhere, in remote as well as, any place. Because, as I said, I don't see any reason to go for a very high power solar thermal power plant or solar PV power plant, because you have to redistribute them and you will lose a lot of power in that. So that is one thing. And another thing, on the cost of SMR, the lifetime of SMR, which we consider, is very important. See, if you look at the SMRs, their lifetime is 30 years to 80 years, people have proposed. Now, the one which is 30 years is apparently going to be much more costly compared to the one which is 80 years. And again, the 30-year SMR of, let's say, if you take small 10 megawatt electric, and if you take, let's say, 100 megawatt electric, that 100 megawatt electric is going to be cheaper, right? So these are inherent things. But then there are certain applications like this, which is very important. Then I also want to add a little bit about that Indian high temperature reactor program. See, actually we started this at that time, I was also involved in, what we call the compact high temperature reactor, and which was a 100 kilowatt LBE cooled, lead bismuth eutectic cooled. And, main purpose was to generate hydrogen, not only hydrogen, any non-electric applications. And hydrogen was prime, and, sulfur iodine was the process which was in our mind at that time, because sulfur iodine needs a temperature which is 950. So we went for the 1000 degrees centigrade. And remember, in those days, we actually demonstrated a simple loop with LBE, which could go up to 1250 degrees centigrade. We have been given permission to operate. And mind you, that was the only loop, where I have seen temperatures in 4 figures, 1000, 1100 degrees centigrade, we went easily. And that loop is still existing in Hall 7, I suppose. And it was at that time the world record. World record, see, the MIT had up to 850 degrees centigrade. We have been given permission to go to 1250. We had gone up to 1100 degrees centigrade. We could see clearly on the thermocouples, the readings. So it is possible, but, the issue is, these are all, long-term projects, See, the material which we had to develop there is niobium zirconium alloy. Niobium, as you know, that in world, I think, if I remember correctly, the only source of niobium is Brazil. And zirconium, of course, and the problem is niobium is costlier than silver. So there are issues, but, when we started with heavy water reactor, heavy water was also very costly. Now, we are exporting heavy water. We could make it much cheaper than what it was originally. So mass production can really bring down the cost tremendously. And I think I will stop here.
What I will do, can I go ahead?
Yeah.
I have some questions and...
Yeah, okay. Do that, but there are some residual which have to be responded. But you please do that.
Maybe I will do
Then
that
we-
and then we will
but then we can
bring that
get
back.
more questions from the audience.
I just went, ex-President Kovind had come and I took it to a company called Agnikul. This is a company incubated by us and located at the research park. This make rockets for 100 kg or 300 kg payloads. The ISRO and other organizations uses rockets which are 1000 kg payload, 2000 kg payload and 4000 kg payload that they are making. And of course they are very expensive. This company Agnikul decided to make that it will make 100 kg payload. But in terms of per kg, objective was to cut down the cost by a factor of 10. Today, they have already reduced the cost per kg by a factor of 4. The rockets are being actually made here and is going to be test fired sometime in a month to 45 days. The way to go about doing it was different. Instead of making one rocket at a time with lot of efforts, they were mass producing. Objective is to make 1,000 rockets a year. That is the ultimate objective of doing something like this. So what mass production, standardization can do, one cannot even imagine. So this is exactly what in my mind is. Whether possible or not, well, we will see in future. But today, for example, this research park uses a 5 megawatt diesel generator. Can I make a 5 megawatt electric micronuclear reactor? Can we manufacture 10,000 such micronuclear reactors in future, a year? If we can do that, then every diesel generator it will replace, but it will not just diesel regenerator. Because if I'm going to use solar and wind, which I'm already doing, I'm bringing solar and wind here, that will not be 24/7. So I'll have to have either a generator or something like that. Can micronuclear generator become a load follower and actually whenever solar and wind is not available, it turns on and gives the power. I'm not talking about base power. Base power may also be there, but out of 5 megawatt, maybe 1 to 2 megawatt can be the base power, but the remaining 5 up to 5 megawatt, can it do that? And can it be mass produced? This is what we have in mind. Tomorrow's focus is going to be this, and I want our panelists probably to respond that is it possible? And there will be one matrix which is there in the, what will be the preliminary business plan? Today, if I produce solar, I can produce solar at 2 rupees per kilowatt. Wind easily at 3 rupees per kilowatt hour. Coal, if it is a coal with all the pollutants, the new coal plant with all the taking care of all the pollutants, it will be more like 5 rupees, 5.5 rupees. The old plants maybe are rupee 50 to 2 rupees per kilowatt hour, but 5 rupees. If I'm using gas, it is 14 rupees per kilowatt hour. If I'm using diesel, it is 30 rupees per kilowatt hour. What will be the cost if I make a micronuclear reactor? That is the direct question that I'm asking, and can we actually make it? I would like the panelists to respond. Tomorrow we'll discuss that.
Yeah, I want to just address can I get that paper? No, this color mic is there. This is there. No, let me sort of fill in some of the residual, I think I should fill in. And then if the time is there, maybe we can go on. But Professor Junjunwala, you might have something more to say,
Yeah,
so maybe we should come
maybe
back.
you do this so that this question can be done, and I have one other question.
Yeah. So let me first question of the levelized cost versus how does the nuclear cost compare with this? That question was there. Dr. Nayak responded to that. But just to add, the nuclear tariff today, unfortunately, it gets front-loaded. Front-loaded in the sense, see, we use levelized costing for purpose of comparison. But in terms of actual tariff fixation, one looks at the return on equity, payment of loan on the interest that you take, and there is the period within which this has to be done. There is a period for equity, a period for loan, depending on how the loan. And this is all commercial thing. Nuclear doesn't benefit from the quote-unquote green financing and things of that kind. So NPC is making profit in spite of all that. So I just wanted to add that if you really go to levelized cost, the tariff will become much cheaper. That's a policy matter again, what should be the principle, but there is some discussion on that. But I just want you to know that today nuclear unfortunately is front-loaded. The tariff of nuclear electricity 20 years down the line after the plant is commissioned becomes cheaper because the capital cost gets paid off. So there is a point to discuss and refine there surely.
Sir, how many years is it front-loaded? How many? Loan is supposed to be paid back in how many years?
I think it varies from what kind of loan instrument it is, but it's roughly around 15, 20 years.
Yeah, solar is 20 years typically at 10% interest. But maybe nuclear.
Yeah, but solar, at the point that was made, essentially wherever there is this bidding, plant awarded on the bidding principle, they are all levelized tariff. So
it's 20 years.
There is that difference. So that point was well made, and I thought I'll just clarify that point.
May I add one thing about? So this levelized cost for those nuclear reactors whose lifetime is extended, that turns out to be cheaper than any of the renewables. If you look at
it, may come down to as low as 1 rupee 10 paise or 1 rupee 50 paise or something. The ridiculous number.
Yeah.
At what interest rate?
No, because they have already recovered
money
their
paid back.
So suppose it's levelized and it is done for let's say 40 years and say interest rate is 8%. What will be the cost?
He was not talking about levelized. Right. He was talking about the plants which have paid back their capital.
I'm saying suppose we do levelized and we take 40 years, 8% interest.
See,
what will be the cost?
If you are talking about new construction, if you are talking about new construction of nuclear reactors, that the levelized cost is varying from $50 to $100 per megawatt hour.
Rupees per kilowatt hour bolo hai.
$100 is.
Anyway, you can convert it.
Yeah, 4 to 8 rupees. This is.
All right.
8 rupees per kilowatt.
Right.
There was some question about privatization. Now, privatization is a buzzword, and it arises from the mindset that anything in government is inefficient and anything in private sector is efficient. Please get rid of that concept. That is not necessarily true. There are very inefficient private sector operations and there are efficient public sector operations, and of course vice versa. So you may have a basis to whatever you're saying, but that's not the core fundamental kind of logic. The second part I wish to make with specific to nuclear is, handling reactor business is not a big issue. The big issue is the fuel cycle. The nuclear fuel, particularly when it comes out of the reactor, number one, it is radioactive and it has to be done, the reprocessing has been classified world over as this quote-unquote sensitive nuclear technology, because that is where the fissionable material gets into loose form, either in a liquid solution or in a powder or in... So preventing diversion on a large-scale operation with such plants is a fairly big challenge. These are all supposed to be under safeguards. Material has to be accounted right up to gram level or finer. And I know in United States, for example, they have followed an open fuel cycle. In the sense, spent fuel as it comes out, it is waste. Essentially on account of this fear of diversion. But then what happens? That doesn't, whatever is there in civilian domain, that has to be still under inspection and control. So you just retain that as a burden for you. And in US, they have not been able to solve this problem. Power plants are being paid by the US government certain money for their holding the spent fuel, because they have not been able to take spent fuel to repository, even as spent fuel. So forget about reprocessing and all. Now that is not a sustainable way of handling nuclear fuel cycle. So in the context of privatization, it is my humble and considered opinion that this country should not think of privatization of at least the fuel cycle operations. So when you talk about privatization, you have to think about a hybrid where you can think of a power plant being done the normal business way, supported by a fuel cycle which is completely in public domain. Now, and this country will take, there is a mindset issue. But I'm saying this just to start a debate. Unless you are reconciled to this, you will not make this progress. This I had said even when the civil nuclear cooperation was being debated, industry was very keen. They wanted the privatization tomorrow. And
so, sir, from what I understand from what you are saying, any entity which will use has to get the fuel from Atomic Energy and has to return the spent fuel to them.
And
that's what you are saying.
absolutely.
I think that is probably a best approach, because you won't be able to handle it very well.
Yeah.
So that approach, I think,
Correct.
is what we will take tomorrow also.
Exactly. So in that context, particularly the high temperature reactor, let me say a bit of tomorrow's today, preempting this issue. I think there is, as I was saying in my talk, for me, this framework of discussing in a composition of discussants of the kind that we have here is very important for creating a new framework of taking things forward. Now, in the context of micronuclear and in the context of hydrogen that we're talking about, I think we should aim at talking about a micronuclear reactor, which is a high temperature reactor, which will produce electricity, but can also produce hydrogen. So that, because that's where you will have the load for both of them. And see how you should do that in, number one, super safe manner. In the sense, you can make configurations of the reactor where there will be no heat up. And these two gentlemen have been working with me on AHWR, and we have shown that it's possible to reach configuration where there is no core heat up. This is one of the fundamental tenets of nuclear accident. But we could do that, and this is number one. Number two, make sure that the reactor, as Dr. Jhunjhunwala says, it must be mass-produced. But at the same time, fuel is like a cartridge, comes from atomic energy, goes back to atomic energy. So that's another commercial service. If you can configure a thing like that, I think it should be possible to do that. There is a question about corporatization. Now, I don't understand. That's only one way of running business. And you want all business to grow, and eventually they will get corporatized. So I think we don't have to bring that into our discussion. Yeah.
I have a couple of more
There was one
questions.
point on education. I think that is well recognized, that we must. So there have been this exercise that if the employer is only one, Department of Atomic Energy, and then you spread education thinking that things will grow, and if the person doesn't get selected, there is a mismatch. There was a mismatch of this kind in aeronautical sector some time back. But if we do it in the mode which we are talking about, then there is a much wider spectrum of employers. Surely there has to be a much larger education program, and that has to grow. So I think we can dispose of
Sir,
it.
I will just take that.
All yours.
Nayak sir has written a book recently, about 6 months back, was it released? Where it's trying to sort of, in a very simple language for lame persons, all the risks associated with nuclear, how to handle this. It's a very, very small booklet. I'll say it's not very small booklet. And I think what we need to do is carry this kind of message in almost all programs, education programs. But I have some other questions, two very specific questions. We all recognize nuclear can play a very important role in our greening our future. Why has nuclear energy in India been moving so slowly for the last, and what will change? I don't see things changing. Now, micronuclear, of course, is different. If we can go there and maybe able to open it up. But in terms of medium size and large size plant, how will we really start growing that? That's a question number one. Question number two, you have been talking about thorium and others have been talking about thorium. I have heard about thorium from you about 10 years back, but we seem to be making very slow progress. When will we start using thorium? So these are two questions that I have. Any of the panelists can, maybe we can start with the various panelists, start from that side. Few minutes, each person can go and count.
The first question was a policy question, that why nuclear has gone so slow. We should have made it like rocket science. Probably this is the question. It's not India. If you look at globally, today close to 400 gigawatt electricity nuclear are operation. But they were in operation, I will say that almost 30-40 years back also. 1970 to 85 till the, I'll say, Chernobyl accident occurred, PMI accident occurred, almost 400 reactors were built in a span of 10 to 15 years. Almost 30 to 40 reactors were being built. So the number which say there was concern, can we get 2,500 gigawatt? I said, this is nothing to accomplish in today's technology. But much before that, I'm again sensitizing the audience here. Electricity, not only in India, globally is only 20% of the total energy consumption. Large fraction is transport and industry. These are the two major things. And this is going to continue in the same fashion ahead also. Transport to decarbonize, industry to decarbonize, hydrogen will be a major source. And that cannot be concentrated. That is why nuclear also has to be decentralized. Not that a big 1-2 gigawatt plant at one place provide electricity and do it. It's difficult. So that is the prime number one. Second part is that why we are moving slow, because I started this answer some time back. If coal, oil and gas were to continue, we don't need nuclear till they are available, till the last drop is available. Because the survivability of the planet and habitat is a question. We all are sitting here and you are listening to us. That is why it did not happen yesterday and it's going to happen tomorrow. This is the answer to you. Second and most important question is the thorium. Thorium, as you know, it is a fertile material. It is not a fissile material that I can put into the reactor, it can burn. It needs a driver. And that is why our architect, Dr. Bhabha, had conceptualized the 3-stage program. We go first natural uranium, then from that get plutonium, then go to third
Sir,
stage.
we have to wind up in 2 minutes totally.
1 minute,
So if we
actually.
can each
Yeah.
get 1 minute, maybe. We have 2 more minutes.
Yeah, so I'll just finish it in less than a minute, I'll say. So thorium, we have to drive it in a very, very, I'll say that judicious manner, because thorium, I said today is also like gold or diamond for us. If I've listened to Dr. Kakorkar's lecture in the morning, he's talking about the early induction of thorium, even for PSWR, in the form of halide thorium. Unfortunately, the technology for production, we don't have a time to collaborate with some foreign agency. If that happens, I will say the door is open today.
Diwakar, sir.
Today's discussion, the point is that we are at a point of where we can make a difference today. I mean, these developments are required today. So the SMR technology, the microreactors, if they are brought in today, it will help us a lot. The imperatives were probably not there 10 years ago or 15 years ago. Now, we also have in place a number of technologies that are with the private sector, particularly with respect to the manufacturing. Manufacturing for nuclear reactors has always, we have partnered with the private sector, we have partnered for components, we have partnered for systems. And this represents an opportunity for participation across the country as such.
Sir, Vijayan, sir.
So, regarding this question, how can we make faster progress? As Kakorkar Sahab has already given his, opinion that in India the implementation of nuclear, although the technology is available, but the implementation has been slower and slower compared to many other countries. In my opinion, if we switch to, let's say, micro or SMR, and if we also switch to that, the hybrid things, especially we say solar PV, etc. is this, but it is not continuous. The nighttime power, actually in India it has not been implemented, I suppose, but in Europe and all that, the nighttime power cost is very high, because solar is not available. So there, if we can do that hybridization with micronuclear, that will make a much larger impact. Even the acceptability of solar PV and solar thermal. Solar thermal also needs hybridization with other source, because in the night time there is no solar energy. Normally they are hybridized with gas, but there again you can hybridize with solar, with nuclear, so SMR to be precisely, and that is the way to go ahead in my opinion.
Thank you. Kakorkar, sir.
Well, half a minute, 1 minute?
Oh, yeah, that's all. Sorry, sir.
All right. So I think I'll give only bullet answers. Why didn't progress very fast? Simple. We had initially to develop technology. Today we are, talking about we have the technology, but it took decades to do that. And it had to be done under a regime of embargo, technology denial and things like that. More important than that, we are talking about gigawatts and all. If we lived under a isolated condition and the uranium that we have only within the country, obviously it's not possible. So we were limited by technology, which had to be done in-house, indigenously. We're limited by the material supply or international trade. Today that is behind us. Now, the third factor is this mindset, fresher, and that's where I'm very happy that you have this discussion, because that is also equally important in making fast progress. On thorium, of course I had given the answer in my lecture, but the simple answer is we have to push 3-stage program for long-term use, because that's the only way. Thorium doesn't have fissile material. But then now that we are talking about the PSWRs, which are our which is the workhorse for the large-scale implementation, that has a very low burn-up. So there is a huge spent fuel management required. You use thorium, you shrink that, and you lose nothing. You do it at a better economy, better safety, and and that's also a work in progress. So, but I think that's the way to introduce. But thorium does remain. Long-term energy security of this country does depend on.
Thank you, sir.
Done.
Thank you. And we will have to wind up in time because we have another session starting at 1:45. Lunch is downstairs, one floor downstairs. There is a staircase that you can walk one floor down and come back at 1:45. At 2 o'clock, we'll start the CSIR workshop in parallel. That will take place in the ground floor of E block. Ground floor of E block, is that correct? Ground floor of E block. I want to just end by saying, of course, tomorrow's we'll discuss this in more detail. We have 4 hours. But just wanted to point out, I got very good answer. Yes, that inexpensive coal and oil would be a big push towards any new technology. And I can understand that. I think I also got an answer, but I think thorium is something that a lot of work has gone on. How quickly can we get there? I still don't have a very good sense. But
Tomorrow, you'll get the answer.
We'll probably get the answer tomorrow. Thank you very much. And I think with this, we'll wind up.